Salamun alaikum. Can you hear my voice? If yes, please put a sign in the chat room. Okay, thank you. Okay. Bismillah ar-Rahman ar-Rahim. Happy New Year and Happy New Term. In this term, I'm with you with the course Advanced Computer Networking. In this course, we talk about some special and some advanced technologies in computer networking. The reference of this book is of this course is this book, Computer Networking: A Top-Down Approach. I'm using the 8th version of this book, which is published by Pearson Publisher in 2020, last year. In the home page of the course, I prepare a link for you to download the slides of the book, and also I prepare another link to download the electronic version of this book, PDF file of this book. Computer networking book nowadays is the main reference book in the course of in computer networking course all around the world. If you search on the web at different universities, you can see that the professors say, okay, use this book as a main reference. But why? In this book, James Cruz and Kate Ross propose another view to computer networks. How? In old view, some great writers, for example, Tannenbaum or William Stallings, they start to write about the computer networks from bottom to up, from physical layer to application layers. For example, William Stallings starting from physical layers and say, okay, when you are creating a network, there are several signals with this modulation and using these technologies and something like that, to say that, okay, some signals are transferred from one side to another side. But what's that signal? I don't know. It doesn't make sense. Those view or those picture was not good for understanding. But Cruz and Ross try to look at computer networks from top to bottom. They're starting from this point. Okay, what is internet? What are applications over internet? What is the structure of internet? What can I sense about internet? They're starting from this point. And it makes sense for me, because I know what is internet. I have my sense, my special sense about applications over network, about, for example, Adobe Connect, about Golestan, about LMS, about news websites, weather websites, everything, governmental websites, I don't know. I have sense. And experience about them. I chat. I use, for example, Skype for chat. Skype, WhatsApp, Telegram for chat, for video chat, voice chat, or text chat. I have this experience. It's very important. Ross and Cruz start from this point. So, as a reader, I can create a direct link with the writers, with the content of that book. And I can understand concepts very easily. So this book is the main reference of computer networking at most of universities all around the world. Okay, we will start from chapter 1. In this chapter, we try to get a big picture from terminologies in computer networking to some other topics. For example, we are starting from structure of internet. We define internet and we try to make it clear what is the structure of internet, what is network core, network edge, what are performance parameters in networking, what about security topics, protocol layer suites, and something like that. Okay, so we start from introduction. Okay, what is internet? Before of everything, before of start to talk about internet, please look at this. When I'm writing internet with capital I, internet, something like this. Look at this. The I is capital. The first I is capital. The internet with capital I means internet that is in my mind. A very big network connected billions of systems are connected together across the internet. So when I'm using the capital I, means that internet. But if I replace the capital I with a small I, it means an area or a part of internet, not all of internet. So be careful about writing this I, using a small I or a capital I. Be careful about this. Okay. Let me look inside the internet, and firstly, let me look on devices on internet. Internet is divided into. Internet has 4 categories of devices. The first category are end devices or hosts. What is an end device? I can say an end device is the user of internet. End device is source or destination of a communication. An end device uses internet for its application. For example, Skype uses internet to transfer voice or video or data from one site to another site, from one person to another person. End devices are running applications over internet or network applications. So they are user of internet. For example, a smart phone, a laptop, a PC, an intelligent car, a server, a data center. I can say that, okay, the traffic is started or ended in us or at end devices. So an end device is a start point or end point in communication. Here you can see some blue partitions or clouds, blue clouds. We call them network. A cloud of network or a network. A collection of devices, routers, and links connecting some systems together. Those networks are connected together using some communication links, some wired or wireless communication links. So there are several communication links too. Here you can see them. Those communication can be fiber cables or copper cables or wireless links. I don't know. Those links prepare some bandwidth, some transmission rate for me to transfer my data from one site to another site. And also you can see some special devices here in different networks at the edge of them or in ISPs. Look at this. What is an ISP? What is your idea? What is an ISP according to this figure? Let me know. What is an ISP? Write in the chat room. ISP has a job, has a specific task. According to this picture, what is the task or job of There is no answer. You don't know what is an ISP. Look at this figure. Let me zoom it. This is an ISP There are two ISP here. In ISPs, you cannot see end systems or end devices or hosts or something like that. ISPs are just some bridges. Some bridge connecting different networks together. For example, in mobile network, this car can connect to this antenna, and using this link, it can connect to this, for example, network provider, to this content network provider. So an ISP is a bridge. To connect different networks together. This is the task of an ISP. Also, here you can see content provider networks or data centers. In data centers, you can see too many servers together in a small area. There are several, maybe thousands or tens of thousands servers are putting in a small area. We call them data center. Okay. Here you can see some links. They are linked to other ISPs, other networks. I don't know. And here, totally in this figure, give us a small picture from internet. There are several end systems, several access networks, switches, links, and packet switching technology and something like that are presented here. Everything that we need in computer networks are presented here. Okay, let me go deeper, going inside. The first thing is this. Okay, there is something special, we called it end system or host. It's connected to internet to send or receive data. Okay, what are those connected devices? Nowadays we have a phrase IoT or Internet of Things. Internet of Things. In concept of IoT, everything around us, everything can connect to internet. Everything. For example, a security camera, a refrigerator, an IP picture frame, a control cable TV, a toaster, a gaming device, a clock, a glass, a car, smart car, everything, a monitoring reader for energy, a reader for energy, and something like that. Everything can connect to internet, and each of those devices is used for a special work. For example, refrigerator is something important in my house. In a smart watch, for example, smart clock, smart watch can gather several other parameters. For example, blood pressure, my blood pressure, or something like that. Everything can be used here. Okay, wait a moment, please. So in IoT, everything can connect to internet, and everything can send or receive data. It's very important. IoT will affect internet. It will change the face of internet during the next years. However, it changed right now, and you can see everything can connect to internet. For example, in a smart house, you can connect lights, doors, curtains, everything, your refrigerator, or everything to internet simply, and manage them over internet. For example, the lights became off at a special time, or became on at a special time, or a refrigerator can send me a message, okay, when you are coming back to house, buy milk is finished, or buy fruit. The refrigerator can ask me to buy, for example, fruit. This idea means that we need to understand networking and internet completely, because our next year's life is this: everything over internet, everything will be online. Okay, so we need to talk about internet and computer networking more deeply. We define that internet is network of networks. What does it mean? It means that internet is a collection of networks. It's a collection of connected networks together. We talked about role of ISPs a few minutes ago. ISPs are connecting different networks together. Okay, but main question is this: okay, ISPs are connecting different elements, different. Can you hear my voice? Okay. Internet, as we say, internet is a collection of billions of connected things, connected devices, connected end systems. But how can those dumb devices can communicate together? How? It's a main question, how those devices can communicate together. We have a special standard, special things, special topics. It's protocols. Protocol is a mechanism to control the behavior of sending and receiving data between different devices. For example, web protocol, HTTP is web protocol. For example, SMTP for email, streaming video for example, online chatting, online e-learning. Skype has its protocol. I don't know, 3G, 4G or 5G of mobile phone networks. There are several protocols in computer networks domain that we should be we should care about them. Also, when we are talking about standards in networks, computer networks, there are two main categories. The first one is RFC, or request for comment. You can search them easily on the web. The second one is IETF, or Internet Engineering Task Force. It's a big organization in the field of computer networking. Most of internet standards are presented by these two, by RFC or IETF. Most of networking standards. However, there are some special standards, which are not presented by, for example, an RFC or by IETF, like Bluetooth. Bluetooth is an industrial standard. Some main companies in the field of networking or in creating hardware for computers create Bluetooth standards and working on that. There is no relation between RFCs, for example, and Bluetooth. They are completely separated. But we need to create these standards to define protocols, to make it clear how two different devices can communicate together. Okay. Another view about the internet is service view. Service view means that, okay, I'm using internet. For what? I'm using internet for what? For which services? What does internet prepare for me? We can say internet prepare infrastructure for us. What is infrastructure? Infrastructure means a platform for communication. For example, now I'm talking with you. You can hear my voice. How? How you can hear my voice? You can read my text. You can view these slides. How? There are several protocols. Which are used here. Protocols for web, streaming video, multimedia, teleconferencing, email, game, I don't know. All of these protocols are running over infrastructure. All of them. So, as a service view, internet provides an infrastructure for us. for communication. So the only things that we need is a programming interface for distributed applications. How distributed applications can connect and communicate together over internet. Just by using programming interface. How we can send or receive data. This is an interface. You can define different options or something like that for communication over internet. So programming interface is very important for us. The next question is protocol. Is about protocol. We say that in the last slides, we say that we have something special, which is its name is protocol. But what is protocol? Make it clear. We say that protocol is a tool to define the way of communication. Let me use an example. What time is it? Who can answer me? What time is it? Answer me. Or what the time is? What the time is? Or what time is it? Answer me in the chat room. Can you hear my voice? If you can, please put a plus sign in the chat room. Please, if you can hear my voice, put a sign in the chat room. Okay, what time is it? Answer me. Everyone, please put a plus sign in the chat room. Everyone, all of you. All of you, please put a plus sign in the chat room. What the meaning of time? What's the meaning time? What time is it? When someone asks you what time is it, you must look at your clock and say, for example, okay, time is 6 o'clock, for example. 10 minutes to 6 o'clock. Just the answer. It's not hard. It's a human protocol. When someone asks you what time is it, you must look at your clock and say, okay, the time is blah 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 something. And if you have not a clock, you say, oh, sorry, I have there is no clock. I haven't a clock. Okay. It's a protocol. So, when we are talking about protocol, firstly, we should define format and order of messages, send and receive messages. And also, we should understand those messages and taking an action against them. For example, when I'm saying what the time is, you hear my voice, you think about the question. Okay, this sentence is a question. He is asking me about the time. Okay, he is asking me about the time, and I should look on my clock and say, okay, the time is 16:20. Okay, this is a human protocol. So protocol is not something strange. It's completely clear. This is protocol. And in a similar way, we can define protocols for networks, for communication in computer networks. Just we need to define format, order, meaning, and taking actions in different cases. Nothing else. Here you can see two different protocols, a human protocol and a computer network protocol. In the left side, it's a human protocol. Alice asked Bob about the clock, and in the right side you can see TCP connection request reply, and at the end you can see that give me that file, and it's return the file. It's protocol. A system cannot directly ask for information. Okay. Now we have an idea about internet and protocols. Next question is what is the structure of internet? Maybe someone tries to have a closer look on internet. Okay, an internet consists of some special parts. The first one is network edge. Network edge is the place for end systems, for hosts. You can find hosts or end systems on network edge. client servers, smartphones, and other things. They are staying at network edge. Here you can see red circles around the network edges. Okay, and as we say before at this course, we can say that the network edge is a place for creating or consuming data. Is starting point or end point of communication. The second part is network access and physical medium. Network access means a network to connect different end systems, connect network edges together. It can be wireless, wired or wireless communication platform, communication media. We should talk about them. For example, here in the mobile network, you can see everything is every client or every end system has are connected through wireless to the BTS, and for example here most of connections are wired, not wireless. And another key player in the structure of internet is core of internet or network core. Here you can see that when we are talking about network core, we are talking about ISPs. In network core, there are several connected routers together. The network core can create network of networks or internet. So when we are talking about network core, we are talking about routers, switches, and communication links, and nothing else. Okay, let me go inside of these topics. Maybe the one main question is that, okay, how we can connect end systems to the edge router? How? We say, okay, we need a platform for this communication. Okay, but what is that platform? That platform can be a residential access network, and institutional network access, or a mobile wireless network access. For example, in residential network access, we can say that, okay, the access network is a consists of a cable or cable access net, cable-based access networks. In cable-based network access, we have a fiber comes to the houses. Okay. We have a cable or a fiber cable until the house. In house, you can see there is an splitter. It's split different channels over the cable. Some channels are dedicated to TV, some of them are dedicated to internet, and some of them are internet, phones, and TV. But how we can create a group of groups of those items, a group of, for example, internet, a group of TV channels, and something like that. The answer is simple. We can use FDM or frequency division multiplexing. Each channel has its own frequency range. Here, for example, in this figure, you can see 9 channels. Each of those channels are dedicated for one channel. Those channels are completely far from each other. Those channels are far from each other. You can see here, for example, channel 1 is for video, channel 2, 3, 4, 5, and 6 are dedicated to video channels. So simply you can small examples here. In modern telephone network, in old network telephone, these cables can be coaxial, but in modern network, in modern access networks based on are in cable excuse me. In this slide, the link between cable headed and the house is unknown. Here we have an example. HFC, hybrid fiber coaxial. In HFC, the data comes into the house using a fiber cable. And in the house, we have a splitter. It's a split different channels. Some of channels are related to the TV, and some of them are for TV, some of them are for telephone, and so on. Using this technology, using HFC technology, you can see that your bandwidth is increased starting from 14 megabits to 1.2 gigabits. Is a uplink or downlink service rate. Okay, this idea is not cheap because here we have to use fiber, but for example, if I use DSL family, in DSL family, we are trying to define frequency division. How? DSL is not a new technology. It's about its history returns to 35 years ago. In DSL, we are using the phone line. So, 0 to 4 kilohertz the frequency band of 0 to 4 kilohertz is dedicated for phones, public phones, and frequencies over or above these ranges are free. So DSL just simply use those open ranges. And because of this separation between frequency band of phone and between phones and data. We can simply work with DSL without serious problem. Its speed for download is 24 to 55. Its downstream speed is 24 to 52. This speed is for their downstream, and 3.5 to 16 megabit is dedicated for their upstream. So as you can see, performance of DSLs are good, but not as much as wellness of cable modems. However, DSL is too cheap, and okay, it's cheaper, but okay. So when we are talking about DSL technology, we just simply separate different frequencies. Okay, this is the last slide of today's lecture. The next access network is home network. In home network, we have a modem or router, which it connects us to the other worlds. In your house network, you can see here in the house, you can use wired or wireless links in home networks. And maybe some of you say that, okay, I am using a modem, for example an ADSL modem. What about the rest of these items? For example, here we have a router before our DSL modem. In reality, your modem consists of routing policies and its basic combinations. For example, here we can see that, okay, this is for example, here you can see the word firewall or NAT. When we are using firewall, it means that we are trying to block firewall will block their access from the outside of the network. Or for example, NAT is another technology for translating IP addresses together. There are several connected devices. Okay. So in home network, you can find different devices. There is no specific devices between a home network and other networks. Everything is possible and applicable. However, we know that the area of our house is limited. So always home networks are standing among small networks, not a big one. Okay, that is enough for today. Is there any question? Is there any question? Okay, I forget something. In this term, after each chapter, when you finish a chapter, I will take an exam from you. Okay? After finishing each chapter, I will take an exam from you. Be clear about those exams because your final marks are summation of those small exams after each chapter. In addition to exams, sometimes during the term, sometimes I am asking you to do some projects, doing some experiments. For example, maybe I ask you to use Wireshark and doing some operations, some experiments. For example, maybe I ask you to do some experiments. For example, okay, maybe I ask you to calculate the delay between yourself and, for example, the Adobe Connect server. You have to do those homeworks too. How many lectures? I don't know. I give you a link for download slides. You can read them. And finally, I'm asking you my questions from those areas. Okay? I will give you link of the book too. I put all of them in the homepage of the course. You know, link of slides and link of book, PDF of book. But I put it in the WhatsApp too. Let me wait a moment. Okay. Okay, I publish it in WhatsApp. How many chapters? We will talk about chapter 1 and I think chapter 4. Let me look at it. We will study chapter 1, chapter 4, maybe chapter 5, chapter 7, chapter 8, and chapter 9. At least 5 different chapters. At least. We will study 5 different chapters. One, 4, 7, 8, and 9. Okay. Chapters 1, 4, 7, 1, 4, 7, 8, 9, and maybe 5. 1, 4, 7, 8, and 9, and maybe 5. But I give you a link to download the slides from the internet. You can download all of those slides free from the internet. And we will talk about these chapters in our course, inshallah. Okay, is there any question? You can create a special group. In the last term, we had a special group. What was it? Let me. In the last time we had a special group for data mining. I will give you its link. You can join to that group if you want. Okay. I wish the best for you in the rest of today and rest of days in this network. Have a good day and bye.